Same object height, same lens. But now we're going to move the object into 1.3 centimeters. So now we're close to the lens. Okay. Is it going? I guess it is. Okay, so now you guys are getting pretty good at this. You can be doing your own ray tracing, right? First ray that you draw is a ray that comes from the tip of the object and goes parallel to the principal axis. It's going to intersect the lens at exactly the same height of the object. And then it is going to be refracted towards the focal length on this side. Okay. Now the next ray is a bit trickier. We said that a ray coming from the tip of the focal length going through the focal length would be bent parallel to the principal axis, but now we're on the other side of the focal length. So the ray you have to draw comes from the tip of the object and goes through the focal point. Well, how's that going to hit your lens? You have to project it. It's going to end up being virtual, right? So a ray of light coming from the tip of your object that appears to be coming from the focal length is going to be bent parallel to the principal axis. Okay, so it intersects up there. So I'm just doing a construction point over here so that I can get a parallel line. So now you're looking at these two light rays coming from this object, and these rays are diverging. It's not going to form a real image over here in image space. So what you have to do is you have to now see where these rays would converge over here on this side of the lens. So I'm going to draw a dashed line. And I'm going to draw a dashed line. Mr. A, I'm not sure I did this right. You can do the math, and you can draw a third ray which goes from the center of the object, from the object which would go through the center of the lens. Again, but it's a diverging ray over here, but if you backtrack and see where it might come from, you in fact see that all these rays are going to converge at some point over here. So, a ray coming from the object that's parallel to the principal axis is going to converge towards the focal point on this side. A ray that appears to come from the object and goes through the focal point on this side is going to be refracted parallel. And a ray that comes from the object and goes through the center of the lens is going to continue on unrefracted. But the rays on this side of the lens are all diverging, so you have to back them up to a point over here. So now we see that if the object is less than the focal length, then you are going to get an upright image, virtual, and it appears to be magnified. All right? So my object is going to be somewhere. I'm going to have a virtual object now, somewhere over here. Okay? Your image is going to be a negative, and I forget what we put here. Yeah, in the second case, our xi is going to be positive and greater than twice the f prime. Okay. All right, so 3 different ray traces depending upon where your object is located. All right. How are we doing on time?
It is 9:09.
Oh, well, now we can do thin lenses in combination. Okay? New sheet of paper.